Hello and welcome to this almost final tutorial of the Part 1 data preprocessing. I look forward to being well prepared with our data to start making our machine learning models. It's going to be very fun. We just have to hold on for 2 more tutorials and then we're good to go. Okay, so today we're going to talk about feature scaling, which is very important in machine learning. I'm going to explain you why right now. So I'm going to go to Google Sheets to find our data set, and here it is. Let's explain what is feature scaling and why we need to do it. Okay, so as you can see, we have these 2 columns, age and salary, that contains numerical numbers. Let's just focus on the age and the salary. You notice that the variables are not on the same scale because the age are going from 27 to 50 and the salary is going from 40k to like 90k. So because this age variable and the salary variable don't have the same scale, this will cause some issues in your machine learning models. And why is that? It's because your machine learning models, a lot of machine learning models, are based on what is called the Euclidean distance. If you remember that back from high school, the Euclidean distance between 2 data points, between 2 points, is the square root of the sum of the squared coordinates. Well, actually here it's the same. We have 2 variables, age and salary. So you can picture age as the x coordinate and the salary as the y coordinate. And in the machine learning models equations, some Euclidean distances between observation points, for example this one and this one, are computed based on these 2 coordinates. And actually, since the salary has a much wider range of values, because it's going from 0 to 100k, the Euclidean distance will be dominated by the salary. Because, for example, if we take 2 observations, for example, this one, the 9th one, and the 3rd one. Well, the Euclidean distance will compute the difference between this salary and this salary. So let's compute it. That's about, okay, so this minus this one. As you can see, this is 31,000. If you put that in square, okay, let's see, up, square, that gives this. And now let's take for the same 2 observations, the ages. So let's compute, equals 48 minus, it was this one, right? 27. Okay, that's the difference. And now let's take the square, equals this square, 441. So you can see very clearly how this square difference dominates this square difference. And that's because these 2 variables are not on the same scale. So, you know, in the machine learning equations, it will be like this doesn't exist because it will be dominated by this. So that's why we absolutely need to put the variables on the same scale. That is that we're going to transform these 2 variables and they're going to have values in the same range. For example, they're going to have values from -1 to +1 here, and same here, -1 to +1, so that we don't get this sort of problem with a huge number here dominating a smaller number here, so that eventually the smaller number doesn't exist. There are several ways of scaling your data. A very common one is the standardization, which means that for each observation and each feature, you withdraw the mean value of all the values of the feature, and you divide it by the standard deviation. So that's the first type of feature scaling, and another type is normalization, which means that you subtract your observation feature x by the minimum value of all the feature values, and you divide it by the difference between the maximum of your feature values and the minimum of your feature values. Don't worry if you're not very comfortable with the mathematics here, but what you need to understand is that we are putting our variables in the same range, in the same scale, so that no variable is dominated by the other. Okay, so let's do it right now. Anyway, you're going to see how the variables are going to be transformed. You're going to see how they go from having large and very different values to small and same values. So let's move on to R. So here we are in R, and now that you understand feature scaling, let's apply it to the training set and the test set. Here we will just write 2 lines of code, which are, so the first line is training set. So the training set already exists, right? It's this one, the training set. As you can see, it's not scaled. It contains the raw values. So training set equals, and simply now we're going to write scale and then training set. That's all. That scales your training set. Isn't it great? And same for the test set. We will copy this line, paste it here, and we will change training into test, and here as well. Okay, so here I just wrote this. There is something important to understand. This will be the feature scaling block of code that we will be using in our template. However, let's see what happens when I select this code and execute it. So let's select this, execute. Okay, as you can see here, I obtained two errors. Error and call means X must be numeric for the training set and the test set. Can you guess what the problem is? The problem is that, okay, well, it tells us what the problem is. It tells us that X must be numeric. But what does that mean? Well, first, what is this X? X is, for this line of code, the training set, and for this line of code, the test set. So let's forget the test set for a second and let's focus on the training set. So X is a training set and it says that the training set must be numeric. So let's look at our training set. Okay, well, the training set looks numeric, right? Here we have numeric values, numeric values, numeric values, numeric values. But no, actually, there are two columns that don't have numeric values. It's this one, the country, and this one, purchased. And do you remember why? Well, it's because before we had the country written in text and the purchase column written in text with yes or no, and we changed that by putting the categories as factors. That's what we did here, as you remember. Dataset country equals factor of the different levels and labels. And a factor in R is not a numeric number. And when you apply the scale here, X must be numeric. That means that all the columns in X, that is the training set, must be numeric. So this time we're going to exclude the categories from the feature scaling. We're not going to apply feature scaling on those columns. So that's very simple. All we need to do is to take the columns we're interested in, which are, well, the indexes of the column we want to scale, which are indexes. So indexes in R start at 1, so that's 1, 2, 3. So that's the second and third index we want to take to scale the age and the salary columns. So 2 and 3, let's input it. We need to specify here 2, colon 3, and that gets what we want. So now I'm going to copy this, copy, paste it here, here, and here. All right, and now it's ready. Let's have a look at the training set and the test set. So not scaled, not scaled. Let's go back to our code. Let's select this, and now we shouldn't get an error. Command or Control + Enter to execute. Here we go. It executed properly. And now let's look at the training set. All scaled properly, perfect. And the test set, all scaled properly. Perfect, and now our data is ready to offer a good precision, a good accuracy, and a fast work of the machine learning models. And by that I mean that the machine learning models will converge rapidly. Okay, so that's it for feature scaling. Now you know how to apply feature scaling to your data in Python and R. Congratulations, and mostly congratulations because we did all the required steps to pre-process our data. Feature scaling was the last one because the next tutorial will be about this data preprocessing template, and I will just explain how we are going to use it in our machine learning models. It's going to be very fast and practical. So we are done with the data preprocessing. Congratulations, you did the most difficult part, and now it's time to have fun. It's time to start making the models, and I can't wait to start them with you. So thank you for watching this tutorial. I look forward to seeing you on the next one, and until then, enjoy machine learning.